And we'll start by saying that what I do is where the rubber meets the road with the public. I've seen all of these studies on DNA here, and then, okay, fine. And how do I advance that? Okay, good. But when it comes to the public, I can tell you that when they ask a question about anything in science, they want to know what the cause was. Notice I didn't say what the causes were, what the cause was. They tend to blame everything on one thing. Most of my colleagues have spent the last year trying to convince media producers and writers that you can't blame every cold snap on the polar vortex, and you couldn't blame the big cold snap on the polar vortex. And so that goes on a day-to-day basis. But first of all, there's a persistent belief among many meteorologists that talking about climate change on air is job suicide, because there's a group of people that are going to think you're a liberal, I don't want to watch you, that kind of a thing. That is beginning to really change. My friend Jim Gandy on the right started talking about climate change in South Carolina. I did it when I worked in Huntsville, Alabama. Mike Nelson is in Denver. And you're seeing more and more of us begin to do this. And it's very difficult because, one, we're very limited on time. And then we're also limited in our amount of time to explain something that can be rather complicated. A DNA event especially can be very complicated. And I want to show you, this is from Ed Maybach's study at George Mason University. There's that 32% down there who do not think that climate change is human caused. There's about 20% that don't even think the planet's getting any warmer. And for the most part, there's nothing you can do or say that is going to change those folks' mind. And you need to remember that when you're communicating to someone. And the one way to find out real quick if you're wasting your time is to know if they're an authoritarian or not. A show of hands in this room. Has anyone read the book by Paul Baltmeyer? He's a psychologist out of Canada. I highly recommend this book. One, it's hilarious. And two, you will understand, especially if you deal with the public, who you're dealing with. And if you're dealing with someone who's an authoritarian type personality, you're basically wasting your time. So when we talk weather on TV, we're dealing with everyone but these people, because there's nothing we can do with those folks. But the big thing to do when you're communicating anything is to find a great graphic. When the eye and the ear compete, the eye always wins. And this, I'm going to show you two graphics that really made a difference with me for the last 2 years. The first was done by John Cook at Skeptical Science. And there's a very common myth out there that climate change stopped in 1998. How many of you have heard that somewhere in the media? Okay? That is still fairly persistent, but it's beginning to disappear very rapidly. And one graph I submit to you did it. And it's this graph, and hopefully it'll play on here. John Cook put this together, and it's been put out all across the web. If you pick the right year, of course, you can say that climate change has stopped, that the planet isn't getting warmer. But when you put it all together, you see that. That is an amazing graph. And that is the kind of thing that the public really gets. So if you're going to try and say anything about this heat wave was caused by climate change or it wasn't, come up with some way of gelling it down into one very, very simple graph that anybody can get. Now, many meteorologists around the country, thanks to Heidi and Climate Central, are able to get some very high-quality graphics that we can put on in a weathercast that can explain something in about 10 seconds. And I want to show you one, a couple of them actually. One is the one that Climate Central did, talking about how we are now at a new record year, very likely. The last time the globe set a record cold month was December of 1916, is it, Heidi? I believe it is. So graphs like this I can put on social media. I can do what we call iPad weather, hold an iPad up, put it on the air, and show that. That goes across very well to the audience. I don't have to spend a lot of time explaining. Now, in Salisbury last winter, and all of Delaware, we cover Maryland's Eastern Shore and Delaware, we had a pretty bad winter. My wife likes to get out and ride her bike every day, and she couldn't get on a bike for 3 months because we had snowstorm after snowstorm. It was cold. One of the main rivers there froze out to 200 meters. It was a cold, cold winter. And everyone agreed until I showed this on the air. It was an average winter. When you go back and look at about the last 100 years, it was an average winter. People under 30 years old thought it was a really bad winter. People under 40 thought, yeah, this was a pretty bad winter. After I showed this graphic on air, I had two people in their 70s, one was above 80, and he said, you are absolutely right. I've been telling everybody that this really wasn't that bad a winter. People remember the climate for the past 30 years, the past years of their life, and they assume that's the way it's always been. So this was a really good way for me to show the audience, hey, the world has changed a bit. What you think of as a bad winter in the grand scheme of the last 100 years really wasn't. I also like to point out that when they were building the state capitol in Maryland in the 1770s, the architect lived in Baltimore, and he ice skated down the Chesapeake to Annapolis to check on it, and then ice skated back to the north. And he did that more than once. You do that today, you'll drown. So those are just some of the ways that we try to communicate with our viewers about climate change. And I'll turn it over to Heidi.
Excellent. Thanks so much, Danny. You know what? I've got a video, and I actually didn't check the sound, so I was just giving you a heads up that to make sure it's loud enough. So I just wanted to kind of pick up where Danny left off, and more or less say that, you know, Climate Central it's a nonprofit science journalism and research organization, and a lot of what I think we try to do is to kind of operationalize some of the science that's already ongoing so that folks like Danny can use it. So one of our core programs is to work with broadcast meteorologists. That's Mike Nelson right there from Denver. And, you know, Hunter, you mentioned the sea level rise component of attribution. Two of our core programs, in addition to journalism, are the Surging Seas Sea Level Rise Initiative and then Attribution, which is an area that we really see a need to work on communicating to the public in a more real-time sense. And I'll just say that from the Surging Seas standpoint, one of the things that we've been trying to do, so when I say operationalizing, it's to take what we've characterized in the past as these long-term risks, right? So long-term risk of sea level rise at the end of the century, and build tools that allow people, stakeholders, decision makers to look at that risk over shorter timescales. So our Surging Seas tool actually allows you to type in your zip code and then look at the risk over the lifetime of a mortgage. How much more often will I see a coastal flooding event in 10 years, in 20 years, in 30 years, right? So to bring it further into the present, because as we know with climate change, it's still perceived as distant in time and space. And so that's why, you know, I come back to this notion of how important it is to bring climate into our discussion of the weather, to create that climate context when we discuss the weather. And attribution, I think we've really seen that from a communication standpoint, it raises all of these questions. So when an extreme weather event happens, Danny's getting questions from his audience. You know, did climate change, you know, as he said, did climate change cause this event? And so we have to really, as a community, come together and be able to answer these questions to the best of the science. And I will say that the low-hanging fruit is sea level rise, right? So, you know, we know that during Typhoon Haiyan, the sea level rise component did create additional flooding. And one of the ways that we're using our sea level rise tool to work on attribution analyses is to look at the additional contribution to the flood print, if you will. And so Ben, my colleague at Climate Central, has actually looked at the additional flooding due to Sandy, the sort of first case, kind of less sophisticated analysis showed that in New Jersey alone, an additional 25 square miles were flooded as a result of that additional foot of sea level rise. And so when, you know, if Danny wants to talk about sea level rise on air in Salisbury, that kind of an attribution analysis becomes a very straightforward way of saying this is what your community looked like without the human contribution of climate change, and this is what it looked like, you know, in the world with us and the world without us. And then we have the other types of extreme events, things like heat waves, droughts, and flooding events. So, you know, Danny's been one of our just truly excellent communicators from the very beginning, and we started out with Jim Gandy, you know, several years ago, and now we're up to about 202 weathercasters, and we've actually started translating our weekly content that we put out to Spanish markets as well. And we have 37 Spanish-speaking meteorologists who are talking about climate change too. So this is my video, so like we'll see if this works, if you guys can hear it. And this is super quick. This is just a tease, right? So Amber Sullins is one of our broadcasters in Phoenix, Arizona, and she's been very, very interested in how to talk about extreme weather events. Arizona, as you know, had some pretty extreme flooding recently. This is just a tease to a segment that she then goes into.
Children right now.
And this storm is not over yet. I'm tracking all the rain still falling. When will dry back out and how climate change is affecting rainy days like this. Still ahead in your forecast.
Caught on video.
And so basically, Amber comes back after the break, and she uses research from the National Climate Assessment, right, looking at observed changes in heavy precip events to make the connection, the large-scale connection between climate change and heavy downpours. And I think really that, the next level of discussion is to be able to think about how we discuss individual extreme events and how we make that connection for the general public. And, Dahi, the discussion that you just had about heat waves is so interesting because we've been doing some survey work to really understand how the general public makes the connection between extreme events and climate change. And we actually did some testing on the Chicago heat wave in Chicago, where we made very similar statements we used essentially the STOT analysis, but placed it in Chicago and brought in the statement that there were 750 excess deaths during the Chicago heat wave, above and beyond what you would normally see in July in Chicago. And what was so interesting was that our focus group audience, they couldn't believe that more than 700 people in Chicago could die in 1995 because of the heat. And so I think there's a communications challenge around just having people understand the risks of heat. Because when they saw the 700 number, they didn't believe the attribution statement because they didn't believe that many people could be killed due to a heat wave. So I think part of what we've been trying to do is to build a coordinated team of scientists that can begin to really think about how we answer the question of extreme weather events in real time. And we formed a small operational team with colleagues at KNMI, at Oxford, Freddie and Miles, David Crowley and the team at Melbourne, and then folks at the Red Cross Red Crescent Climate Center. And it really is to help inform other initiatives like Peter's Euclea initiative and the ACE initiative out at NOAA to really think about, okay, how do we communicate this? How do we develop a methodology? How do we do this in real time? And to just give one example of a test case that we did. As you guys know, 2014 is very likely to be the warmest year on record. Turns out it's also virtually certain to be the warmest year on record in Europe. And so, our team got together, they did an analysis, and we found that the odds of average temperatures across Europe reaching this year's record-setting levels were likely increased by 35 to 80 times due to human influence, right? So we came up with an attribution statement in real time when the media is reporting on the issue. And then what we did was we actually reached out to 80 weathercasters throughout Europe and provided them with graphics and the ability to put this year's record warmth in context. So I think that there really is, I think, a need to talk about extreme weather events in real time when the media is asking, but we have a lot of hard work to do, and I think we've learned lessons from things like the California drought and what do you do when there's different answers and different ways to define an event. So I am going to wrap it up there. And any questions for either Danny or myself? Mike.
All right, California drought's a good example. There are a number of statements out there. The definitive statement is yet to be made, if it will ever be made. How do you communicate that to the public, where we have some statement right away, later on we have a different statement?
Right.
We're all stupid because we're changing our mind. How do you
Right.
communicate that aspect?
Right. Well, I mean, I think it's a really, really hard question. I think the first answer is careful coordination about what the key framing and the key messages need to be. And I think for me, looking at the multiple objectives of the NOAA report, right? Richard Seeger is a good friend of mine, and for him, advances in seasonal forecasting was what he saw to be kind of a really important takeaway from the report. But I think it's also acknowledging that, when the media looks at an attribution study, I mean, there's a couple of key questions that they're going to have, and I think what can happen with with some of these analyses is that if you say mostly caused by natural variability, there's the risk of the headline being climate change played no role. And I think that was the poor framing from the start. And I think that's something that we can think through, you know, from a messaging standpoint, ways to improve. But it's not to say this isn't going to be challenging and difficult, but I think coordination is going to be really important, and thinking through the key points that we need to make from the top. Because I do think that you know, climate change played no role is actually, it's a really misleading takeaway from an analysis like that.
Can I answer that too?
Yeah, please.
I want to add into that. I wrote a blog post about that paper, and I called it "Beware the Juice of California Cherries," because people were cherry picking that to take one side or another. And what I try to point out in there is Kevin Trimberth's famous statement that when it comes to weather on the planet's warmer. There's more moisture in the air. Everything has something to do with climate change, but this event was mainly natural. But to beware trying to pick and choose one paper to make a statement based on your belief on one side or the other. And I got a lot of good response to that. I think that's the best way you handle it, is you say, yeah, in this case, this would have probably happened even if the planet wasn't warmer, but there was also a factor that we have to consider. We don't know what that factor was, but the planet is warmer.
Can I follow up on that? I'm not sure you really answered my question. What I really wanted to ask is, what happens when we really do change our mind? Because there are multiple papers that come to different conclusions. Some of them are right, some of them are wrong. Eventually, maybe we learn.
And that's what I was trying to point out in the paper, and what I wrote too, is that you can't cherry pick one paper. You need to wait and give it some time to see how the science settles on that. And I think the public understands that.
I just think we need it now.
Well, you know, and I think this is where there's a way to characterize it as, you know, a sort of first best answer. And you know, what I found to be really interesting is that when you have three studies that have somewhat different takeaways, they're reported on very differently than when you have one study with one takeaway, right? Like, it's easier to report on the one study. And so I think as a community we can come up with, okay, the first best approach, and I think the general public understands that thinking can evolve and change. So you know, there's only so much that we're going to be able to do. But I think maybe some of the frustration around the way that the California drought story has evolved is that it's kind of fallen into this zero-sum game. You know, it's climate change or it's not. And I think that there's a way to kind of have a more sophisticated conversation about it. So, you know, what you raise is always going to be true and always going to be a challenge, but we kind of have to build that into the way we go out on a complex topic like that. Yeah, not an easy question to answer. And the beauty is we're out of time, so thank you very much.